A quick introduction to Abundance, which is our 3D modeling program. It's still very much in beta. It's still very buggy. It's actually especially buggy this week because it seems like we created some new bugs when we made it public. But the best way to find bugs is to get everyone's feedback, so we're still going to launch it anyway. What Abundance is it's a cloud-based open source CAD program. So there's a lot of options out there for CAD, but I hadn't found a really good free open CAD CAM program, and especially not a cloud-based one. It's really nice to have things in the cloud because then you have access to your files on every computer. It makes collaboration really easy. It makes sharing projects really easy. The problem with doing cloud-based things is you sort of have to trust the company that's holding your files. Because if they go out of business or if they change their terms of service or something like that, you can lose access to all your work. So what we've created is a cloud-based CAD program where you log in with your GitHub account. So your files are stored in your account. I don't have access to them. No one else has access to them. And because it's GitHub, it makes collaboration and things like that really easy. But basically, if you're not interested in understanding how any of that works, you don't really need to. You can just pretend it's a login like anywhere else. And GitHub just provides like a nice login manager. So basically, we're going to log in here. It's going to load up our projects. And I'm just going to show you what it looks like to create a new project and just some basic overviews of how the modeling process works. So I'm going to create a new project here. I'll just do something basic like a pipe flange. I'm going to do it in millimeters, a basic pipe flange. And we're going to create our project. And so now what's happening is this is creating the project for us on GitHub. Again, these are your files. You control them. We don't have any sort of access to them, but you can share them with anyone you want. Now, the way that Abundance works is it's based on a language. So rather than drawing, drawing-based CAD programs are really good they're pretty intuitive and easy to get started on. But they struggle a little bit when you get to really complicated projects. And basically, drawings are really good for conveying information quickly, but they don't make it easy to modify that information later. Like you can picture, like if someone in France draws a picture of a house, I don't speak French, but I can understand it's a picture of a house. But if someone in French writes a description of a house, I can't understand it. I have to learn French in order to be able to understand what they're talking about. The advantage of a language, though, is if someone writes a description of a house in English and I speak English, it's really easy for me to then go into that description and change the color of the house from blue to yellow. I just need to change one word. Or I could reuse a part of that paragraph instead of using the whole thing, which is much more difficult to do with images. So Abundance is a language-based program. Now, you can write code directly if you'd like to, but we're not going to get into that in this basic tutorial. The way you define the language is by collecting these nodes, and we call these atoms. So atoms are the most primitive, basically, forms of geometry. So here we have a circle, and then we've extruded that circle. Now, if we want to join multiple atoms together, we can create a molecule. And a molecule is basically a folder which can contain atoms. So we can go in here, we can create, say, a rectangle, and then we'll extrude that rectangle up, and we'll pass that out from our atom here. And now you can see here we have our circle, here we have a rectangle. We could then say move, and we can name this. So let's name this cube. We can move this one over. Let's move it. Oh, that's way too much. Move it over 10 millimeters. And then we can do interactions between our different shapes. So we can form an assembly here. And an assembly just puts them both together. And this is our sort of final output shape here. So now we've got an assembly with our two shapes. We can also, let's move this guy over slightly less. Let's move it over 6. Okay, so now we have an assembly here of our two parts, and you'll notice that there's still a line here between the two parts. Basically, that's because in assembly, the two parts remain separate. The circle has cut into the square and created space for itself. Assemblies do not allow interlocking geometry, which is nice because in real life, if you have two parts that intersect, they can't. We do, however, have the option to fuse these two shapes. So if we fuse these together, you can see now we've created a shape with no interlocking there. We can also do a couple other things here. We can do a difference, so we can subtract them from each other. So here we're going to subtract the circle from the square. That looks like it's not happy. I'm not sure why. Oh no, that's just, okay. So, oh no, it's not happy. There's definitely bugs. Let's try going the other way. Let's see if it's happier that way. Subtract the square from the circle. Okay, so that's what we expect to happen. It doesn't love when there is an exact, when there's an edge that exactly touches. So you can see how the circle is like touching there. There's a weird bug with circles we're working on. I think we can get rid of this one if we make our circle say, so now it's happier. But yeah, still lots of bugs, but we can do these different interactions. We also have intersection, which is going to give us just the overlap between our two shapes. Our circle's all messed up. That's why it's upset. Okay, so there's our intersection. And you can see this little gray area. That's just showing what was last connected to the output here. We can turn that off with this option. Another thing we can do is if we have, say, an assembly here, we've got our two parts that are assembled together. Like I said, they're two actually still distinct parts. We can use tags. So we can tag this one as circle, and then put it into the assembly. And now we can see what our assembly looks like, all our parts together. And if we want just the circle back, we can go here and extract back out our circle tag. If we extract out just the circle tag, we can see we just have the circle with the square cut into it. The order of the assembly is important here. The lower up ones get cut by, or so the higher up ones get cut by the lower numbers get cut by the higher numbers. So here we have input number 3 is our circle, and then we've got 5 here, so 5 is going to cut 3, and that's there. If we swap these around, so now we've got, it looks kind of the same, but if we extract out our circle, we can see our circle is not cut, and our square will be cut in this case. Okay, let's go through the process of actually modeling something functional for a second. So I'm going to do just a basic pipe flange here. So let's create a molecule, and we're going to call this our pipe. So let's make our pipe, let's say 100 millimeters around, and we can make it, so we're going to do 100 millimeters. We'll do the wall thickness is going to be 10, so we'll do a 90 here, and then we'll do difference. So we're going to subtract our two circles, which gives us the outside of our pipe. We're going to extrude it, and let's say our height is going to be 100 millimeters. So that looks good. Now, this is one way to do this. So now we've created a pipe. But I actually decided I think I'm going to do this slightly differently. Because one of the neat things that you can do is you can define keep out geometry, which is basically geometry that isn't part of your final construction geometry, but it's geometry where you want other things to not go there. So instead of doing the difference here, I'm going to extrude this guy, and then I'm also going to extrude this guy separately. So this is our smaller circle. And let's extrude this one more, and let's actually move it down slightly. And then we're going to give it a color. And normally you can just change the color of things to, purple or whatever. But there's a special color here called keep out, which is basically, it's sort of empty space that we don't want anything to go into. Because our pipe, it's important that our pipe is hollow, we're going to make sure nothing goes in there. So now we're going to create an assembly with our pipe here and then our empty space. So now you can see we have a hollow pipe, and we've informed the rest of the geometry that nothing can go inside that pipe. So we're going up here. Okay, so now we have our pipe. Let's make our flange. And make a new molecule for that guy. It's generally good practice to always create a new molecule at the top level, because they're much easier to copy and paste and move around if you want to reorganize things later. All right, so we're going to do our flange here. We're going to do a circle. Let's say our flange is 160 millimeters, and we're going to make it, let's say, 7 millimeters thick. And now we can pass it out here. Okay, so we got our flange, we got our pipe, and we can do something neat here. So if we assemble these, we want our flange to get cut by our pipe. Now you can see our flange is around our pipe, but our pipe has cut a hole in our flange here, which is kind of neat. Now we want to add some mounting bolts here. So let's add some bolts. And I'm just gonna make a bolt here. Now, one of the neat things, like I was saying, with a language, it's easy to import. I can't talk and type at the same time. With a language, it's easy to sort of reuse parts of other things. So we can create our own bolt here. Like, let's say we have a 10 millimeter bolt. Oh, so we got 10, and let's say our height, a length of our bolt, we're going to call it. And actually, I think we want our bolt to go down just for the way we have things oriented. So let's make it 50 millimeters down, and then our bolt head, I could look it up in McMaster-Carr, but let's say our bolt head is, this is a big bolt, so maybe 15 millimeters, and that's going to go up. Let's say it's 6 millimeters thick, and then this is a single thing, so we're going to fuse this together, and let's give it a color. And we're going to make this black. Okay, so we've created our bolt here. Now, one thing we can do is we can also import a bolt. So everything that gets created that's publicly shared within Abundance is available to import. So I know that I've already created a bolt. I don't think I've created an M10 bolt, but I know I have an M3 bolt out there. So I'm just going to search here for M3. It takes a little while. Search is quite slow. Something we need to work on. Actually, you know what? I'm just going to search for bolt. Maybe we broke this when we launched it. Okay, we'll skip that for now. We'll do like a more involved tutorial in the future. So we've got our bolt here. Oh no, I need to do this because I want to import rotate. Okay, it's working. I guess I just didn't create a bolt. I don't have a thing called bolt. So we've got our bolt here, and we want to move it up because our flange is 7 millimeters thick. And then we also want to move it out, let's say 130 millimeters. And I glossed over this, so I'm going to show it in more detail. Basically, there's these basic functions that are built into the program, but we know that people are going to want more and fancier features than this. So you can create your own features for the program just by creating a project which does something. For example, I created a pattern rotate option. So I'm just going to search for rotate, and you can build basically any feature you want this way. So Abundance does not have a built-in pattern rotate option, but I created one and I'm able to then import it as if it was a feature built into the program. It's sort of like a package manager. And you can have it, you can make your own pattern rotate, which, like, let's say you always want them to be evenly spaced. Right now mine, you can put in the number you want and the angle you want. In this case, let's say we want 6 of them and we want them to be evenly distributed. So we're going to do 360 divided by 6. So now we've got them evenly distributed. You could very easily make your own pattern rotate which always evenly distributed the things you put in. Okay, now we're going to throw these bolts into our assembly. And it looks like I have messed up radius and diameter here. So we're going to go back in here to our bolt, and we're going to do half of that. So there's our bolt. Does that look better? That looks better. Cool. So now you can see we have our flange. That's just a really basic project. Let's make it a little more complicated. We can give it an input here. And so we're going to call this a pipe length. This is where it's our top level molecule. We've just created an input here. And I'm actually going to add that input here as well. And we're going to connect that to our, we're going to need to do it a couple places. So we're going to, we've got our extrude here. So we're going to tie that in there. And our pipe's really short right now. Let's give it a realistic number so we can see what we're looking at. Okay, so our pipe is 100 millimeters long. But we also need our keep out area, and we need our keep out area to actually be slightly larger than this guy is. So if this guy's at 100, we extruded this one 150. So let's go here, and we're just going to make a new equation, and we're going to call it x plus 50. So we take this guy, we connect it there, and we're going to extrude this one by x plus 50. So now it should always work out that if our pipe length is 100, our keep out is a little more. And if we go 150 on our pipe length, you can see it's all resized correctly. And the really neat thing about adding variables and everything being parametric like that is you've created this project, but let's say you wanted to share this project with someone else. And a classic example of having a variable like this would be your wood thickness. Let's say you've designed a chair and someone else wants to cut out the chair, but they're using a slightly different thickness of plywood. Basically, you can provide an input for wood thickness, and they can enter that value and everything will change. But so let's say you want to share this project. You can click here on this share button, and this is going to give you a link. And this link doesn't work. That's a bummer. Maybe it's going to work eventually. Oh, the link is just generating wrong right now. I can fix that. Okay, so once I fix that, you will be able to give someone this link, and this gives them a basically a parametric thing they can edit. And in fact, you can see this is out of date we hadn't saved our project here with our new input. So now that it's saved there, if we reload our link here, you will see that now this parametric view, anyone can click this link. There's no login required. There's nothing required. They now have a parametric model here. So they can say, I want my pipe to be 300 millimeters long. Now you have a really tall one. Or let's say I want mine to be 50 millimeters long. Now I've got a really short one. And this is, you basically created a parametric program which you can share with anyone, which they don't have to log in or really know anything to be able to interact with and use. And let's make it a little bit more complicated. So let's start using tags. So let's say this is for 3D printing. We'll tag this guy here. We're just going to tell it that the pipe flange is plastic. Or you know what? It's a pipe flange. It's probably not plastic. Let's call it metal. And we'll tell it that this part here is also metal. Unfortunately, we're going to have to delete both of these so we can keep our order correct. Okay, so everything still looks good, but now we have the option here to just give us, we're going to tell it we just want the metal parts. So I'm going to select metal here. And now you can see we are just extracting the metal part, our flange. And we can then download that. So we're going to export it, and we want to download an STL file, and there we go. So now we have the option to export our file, and we support SVG and STP files as well. We're hopefully going to have G-code really soon. Okay, so we got our project saved, and if we share our project, we can now go into here, and basically someone can customize it. They can say, I want mine to be 200 millimeters tall, and then I want to download that STL file. Okay, so back in, and if you ever want to preview what it looks like if you share a project, you can just click run mode here, and that's going to show you basically what people who aren't logged in are going to see. So yeah, that's a basic overview. There's a bunch more cool features. We have automatic nesting and layout of parts for CNC routing, which is slightly broken right now, but that's going to be working again imminently. We have G-code generation coming really soon. But overall, I just wanted to throw this out in the world. We've been sort of kicking the can down the road for like a month now of like not releasing it because it's not quite ready. And I think it's time that we just throw it out there and start getting people's feedback. And also, it's totally open source. If you want to fix a bug, that would be amazing. If you want to report a bug, that's amazing. Just let us know in the forums, and hopefully it'll keep getting better and better. Sort of the only way to really find issues and make things work is to put them out in the world. So that's what we're doing. All right, thanks for watching.